Right, so this session was supposed to take place last night, and we had some technical difficulties, so we rescheduled for it to take place now. So my name's Ashik, that's my website, that's my email, that's my Twitter, and today I'm going to be talking about CQRS and event sourcing, and I talked about something similar at the last MVC Conf, and since then it's almost been a year and a half. So I've picked up lots of new things, or got rid of a lot of other things, and so these are my experiences, if you will. So the talk I did last year was mainly focused around NCQRS and some other frameworks. It was very framework driven, and it was almost as if to apply the techniques you'd have to start from the very beginning and replace large chunks of your application. Whereas I've gone on to find that it's actually quite simple, and CQRS, event sourcing and messaging architectures, they're not necessarily one big thing. They're a collection of smaller, simpler parts, and they can be very flexible and simple and quite easy to get started with. And we'll look at an example application and some other stuff in the session. Right, so before going into the code bits or discussing what CQRS and event sourcing is, let's first kind of see what sort of problems they try to solve. Well, in this slide you can see something that you would typically see in most ASP.NET MVC applications, where you have the UI, you have the controller, you have some sort of repository, and you have a database and database schema, data storage, whatever you call it. Usually that's some sort of relational database like SQL Server, MySQL, Oracle, or something else. And then in order to allow loose coupling, we add additional layers, like say service layers, and terms like domain come in. Right, is the sound okay? I heard something weird. Okay.
Everything appears to be fine on my end.
Okay, cool. Thank you. Right, and then if you look at these two slides, what previously people used to call a business logic layer in traditional N-led architecture turns out to be a service layer, and what was a data access layer turns out to be a repository layer. Now, obviously, from this slide is more focused towards something like domain-driven design, whereas this would be a traditional N-layer application. Now, it seems the difference between them two is just the names. The layers are pretty much similar to exactly what they were before. And then we have some more layers, like say we've got some UI validation, we do some DTO transformations for view models, and lots of other DTO transformations go down through the layers. And terms like lazy loading, IOC containers, projection, caching, all of these start piling on one on top of the other. Now, ideally this should be a good thing. You can take your service layer out and replace it with another implementation, hook it up with the IOC container, and you've got your new service layer working. Same for the repository, same for your data access, or whatever you call it or use. But typically, applications don't take out whole layers all in one go. They usually add more features to, change some features, add new features, or remove some features, but they don't take out entire layers in one go. So, although this sort of layered approach helps with replacing one layer in its entirety, when it comes to making modifications and changes, that turns out to be a problem. The main reason is, say you want to change a many-to-many relationship to a one-to-many, or a one-to-many relationship to a many-to-many. The change you do to your database schema kind of gets propagated all the way up to the UI. and until you've made the changes to all of those layers, you can't really release your application. And so we have all these layers of abstraction that should enable us to change bits and pieces independently and quickly and efficiently, whereas it turns out that that doesn't happen. It causes more problems, and you have to kind of touch upon multiple layers when you're adding new features or changing existing features. And so making changes becomes harder and harder. Right. Someone's just mentioned they've lost audio. Can everyone hear me? Okay, cool. I'll continue. So making changes becomes harder and harder, and as the application gets larger, this problem increases. Also, when backed by a relational database and you're doing lazy loading across, or making changes across 6 or 7 tables that are joined together via foreign key relationships, transactions can get quite complicated. If you're affecting multiple databases, it can be even more complicated. So that can be slightly tricky. Also, you have to do a lot of technical work rather than focusing on what the business actually cares for or wants out of the application. So they pay for all the implementation of all your layers, but they get, well, little features in return, if you will. Testing becomes quite complicated, and different people take different approaches to testing, and testing of properties for domain objects or whatever becomes increasingly harder, and testing your domain involves complicated mocking and all sorts of complex, depends on who's using it, but relatively difficult to use tools. And also, it's pretty much an all or nothing thing. Say you're adding a new feature. Until you've added that new feature to all of the layers, you can't actually deploy your application. If your service layer does not agree with your database schema, you can't ship your service layer without upgrading your database schema. Or say you've updated your database schema, it could very well be that the service layer no longer agrees with it. So making changes or adding new features becomes all or nothing. And as applications grow bigger, complexity increases. Right. Is audio choppy for everybody? Okay, cool. Right, so as applications grow bigger, complexity increases. There's also an increased requirement in terms of knowledge. Everybody working on the application has to have a significant amount of knowledge regarding almost, if not all, of the layers. So for a certain feature, they need to be aware of how the database, which database tables affect that feature, also which other database tables are related to the tables that are required for that feature, and same goes for all the other layers as well. It's also difficult to scale. Relational database with all its foreign key relationships, unless planned quite well, can be quite complicated to shard out to multiple servers in terms of data, and is difficult to version. Say version 1 of the database and version 2 of the database could require complicated modification scripts, and maintaining that you have to do some roll-up, roll-back if you're doing something like continuous delivery or something, and it can be quite complicated to actually achieve and time-consuming as well. It's also difficult to integrate. If you've got a lot of applications across your organization and they need to integrate with each other, you may need to implement some sort of expensive anti-corruption layers in order to ensure that the two applications are sufficiently decoupled. Whereas if you're integrating via WCF web services that know about the schema of the other application, if you will, then when one of the applications change, they have to maintain that backwards compatibility, and that can be quite complicated to do. Right. So instead of going on about that, let's think about how we can change this and how we can simplify this. And over here is a diagram that kind of represents what a CQRS-based application or bounded context or whatever actually does. You have your application over here that requests something to do something. When that something does something, it tells everybody else that it did that thing, and the application simply fetches the data from some subscribers to those things that hold the data in the way that the application wants it. And in CQRS terms, different names are used, but typically we would call this the domain, and we would call this the read model. Also, the thing that carries the requests from the application to the domain, whereas it says please do this or please do that, we call it the command service. Different people call it different things. Some call it the command bus, some call it the application service or whatever. And the thing that carries the I did stuff or events from the domain to the read model is called the event bus. And the thing that holds the data in a query-friendly fashion is typically called the read model. Right, now there are different approaches to achieving applications like this. One of the simplest forms that typically you can apply to any application, pretty much any application that you do today, would look something like this, where you've got the UI sending commands to the domain, and the domain querying the database and updating it based on what's taking place, and the UI reading data from that database. Now the difference between a typical M-led application and this would be that the read operations would be done through a different path from the write operations. And when I say write operations, I mean things that actually change something, like say a database update in this case. I'll create, update, or delete anything apart from read. Now the benefit of this is that your UI, when querying for some information, will not actually cause any changes to the database. And all of your relational integrity and foreign key relationships and all of that is pretty much in place to ensure that your data has integrity. It's not corrupt. But you can't possibly cause your data to be corrupt when you're simply reading information. So instead of going through all the layers and services and business logic that only take place when you change something, you can simply query the database directly. So on the left side of things, so on the right side, left side meaning the side that writes, you could use your traditional approaches for services and ORMs and whatever, whereas on the read side you could use something that's much faster and effective for querying, like say Dapper.net, or even if you're using Hibernate, you could use the iSession directly without going through all of the layers. The second approach is that instead of having the same data storage servicing both reads and writes, you have two separate storage, two separate sets of data. One bit of data only exists to maintain the integrity of your operations, whereas the other set exists only to be queried. So when the UI sends over commands to the domain checks its own data to ensure that certain operations can be done and makes decisions as to what operations have taken place or what events have been generated, and those events go to the read side and update some query-friendly data so the UI can read from it. And in this way, you're essentially separating the data that's required for carrying out business operations and the data that's required only for presentation purposes, reporting, displaying on a web screen, printing out forms, or something else. The third approach is that since we have all of the events that are being generated from the domain, instead of having a separate storage for them like this, you can simply use those events to hydrate your domain objects when they need to carry out some operations. And this approach is called event sourcing. We'll look at what this looks like when we look at the demo. Okay. Now, among these three approaches, in different scenarios, different approaches would be appropriate. There may be more approaches as well, obviously, but these are the most common. The benefit of the first one is that if you're using a relational schema today, this is very easy to migrate to. You essentially just have a separate path to query your database. It could be a separate interface that does it. So you have one interface to deal with the changes for something and another interface to query the data. Or it could be something much more complex. You could have separate pathways of doing it, even separate servers. With the second approach, you explicitly model that, you explicitly accept that only a portion of your data is actually used in carrying out business operations. And this is quite interesting. Most, if not all, of what you do, what goes on in the business is in reaction to something happening, either from the outside world, someone placing an order, or something internally happening, I don't know, delivery failing or something. But something external causes something to happen in the business. Now, the business doesn't exactly care about how you're storing that data, what your database schema looks like. What they care about is when those things happen, if the correct decisions are made or not. And typically, that sort of decision making does not require a lot of data or rather all of your data to process. We'll look at an example of this in the demo application. With the third approach, you have the added benefits that all the changes that you'll be doing will be done through events, and they will be stored in an append-only event log. So this has a number of benefits, which we'll discuss later. But right now, we can say that it's kind of like a free audit trail. Right. Now, among these three approaches, the first one is safe. The third one is safe. But the second one, if you're not careful, can be quite risky. The reason it can be risky is that when the domain makes a decision, it does two things. It updates its local storage, and it fires off events to update the read model. Now, you can do this transactionally. There may be technical solutions to any problems that arise from this, but there is one problem that cannot be solved with any sort of technical implementation. That problem is that of developer error, or rather, we did not know that we needed to do this at that point in time. For example, if a developer updated 3 tables when a command came in and sent off 5 events instead of 6, then you have a problem with the events that were sent out. Whereas if the developer sends out, say, 6 events but forgot and updates 2 tables but forgets to update the last table, then you've got an error in terms of the updates in the data storage. And if this happens in production, you have no way of knowing which one is correct, which your single source of truth is, because you don't actually have a single source of truth. You have one source, which is the list of events that the domain generated, your event log. You have another source, that's the local smaller database, if you will, that exists solely for the purposes of domain processing. Now, if these two are out of sync with each other, how do you know which one you would adjust to fix it? Right. That's kind of enough of the theory, and we did lots of theory last year as well. So let's go ahead and look at the demo application. The application is actually quite simple. Oops, let me bring this in. It's an account management system, of all things, and you've got an admin panel. You can go into the admin panel and register a new user. Let's call him John, and give him an email of john@example.com, and say his initial balance is 500. And when we submit it, it says your account's been registered. You go back to your admin screen, and it says there's one account with John with an email john@example.com. If you go back to the home page, we can see that the account John is, well, there. And if John clicks his account, or rather we can say this is his login, if you will, it takes him to his page where it says his current balance is 500, and it asks the amount that he wants to debit. Let's say he wants to debit £300, or other. Can't say pounds, units or something. And then it says your request has been accepted and will be processed. Click here to return to your page. He goes back to his page, and you can see that his current balance is 200, and he has a log of things that took place, like his account was registered with a balance of 500, debited 300. Now, if he tries to draw £600, it says his request has been accepted, but then when he goes back to his home page, it says overdraw of 600 attempted, and his balance remains the same. Similarly, if he tries to do this again, and a third time, then we see that his account is now actually locked. So he's tried to overdraw 3 times. It could be some sort of suspicious activity going on. So if he tries to draw something like £10 again, then it will say your account has been locked due to suspicious activity. Please contact an admin to sort this out. You will not be able to make any debits until your account is unlocked. We can go back to his page, and it sees his account is still unlocked. The admin can go in, and this time you can see that there's an unlock button next to John's account because his account is locked. When he clicks unlock, his account becomes unlocked, and John can go in and sees his account is now unlocked and make a debit of 50, which goes through fine, and his balance is now 150. So that's the entirety of the demo application. Not very interesting, but it has some business logic to it, albeit simplistic. But let's look at the code. It's probably a bit more interesting, right? And that's a typical MVC application, kind of simplistic and not necessarily following the best practices everywhere, but hopefully good enough to get the point across, right? The controller is not very interesting. All it does is it accepts HTTP requests and shows various views, or it takes in various commands and does, say, configuration.instance.bus.handle. Yes, I'm using a singleton. You could use dependency injection IC or whatever for this. Right. That's all the controller is doing. If you'll notice, it gets its data from configuration instance read model account infos or account balances, does link queries on them, and when it wants to do something, this is the slightly interesting bit, is it just calls bus.handle. It doesn't know how, say, debit account is done. It does not know how unlock account command is processed or register account command is processed. All it knows is that how register account is processed. All it knows is that when it gets one of these requests, it simply calls bus.handle, or if some people would call it bus.send or something else, it just needs to call that. And if it needs any data, that data is in that thing over there, configuration.instance.readModel. Right. Let's have a look at what the commands are. And to see what the commands are, you can... to see what the commands are, you can simply go into the models folder, and you can see we've got 3 commands. We've got register account, debit account, and unlock account. Similarly, in terms of events, you have account debited, account locked, account registered, account unlocked, overdraw attempted. Now these are all very simplistic messages. You can see that debit account is called debit account because that's what it represents, and it has the information needed to carry out that operation. So it's got the account ID and the amount that you need to debit. Similarly, unlock account has the account ID on it and nothing else, because you don't need anything else. The events similarly are simple flat data structures that simply carry the information along with the intent, and the intent is carried by the name. You might notice that the command names are in the present tense. You can see that it says debit command, register account, unlock account, whereas the events are in the past tense. Account debited, account locked, account registered, account unlocked, overdraw attempted. So these are all in the past tense. And there's a reason for this. The reason is that commands are requests to change something. And although they typically should not fail, you should be doing validation up front for them, they are allowed to fail. The business can reject it. It's like if you see 2 friends sitting next to each other, and you ask one guy to punch the other guy in the face, the guy could say, no, he's my friend, I won't punch him. So that's a rejection of your command. Whereas an event is simply reporting something that's already happened. Some guy's punched some other guy in the face. He's already done it. You can't take it back. It's happened. It's accepted by whatever was responsible for accepting that thing. And an idea of ownership comes into place here. A command should typically be processed by a single thing. One thing should be responsible for any particular type of operation. And once that operation has been completed, the results of that operation, no matter who it goes to, they have to accept it. If their own rules don't agree with those events, then those rules are wrong, or there's some sort of inconsistency in the system. However way you put it, the authority for carrying out the operation of that command is the thing processing that command. And anyone responding to events does not have the authority to reject that. Right. So that's the commands and events. Let's actually look at what the application service looks like. Many people call this many things. I've called it an application service just to, keep in line with traditional notation, if you will. There's an application service, and it's taking in a repository. It doesn't really know what sort of repository it is. All it knows is that it's a repository. And it has 3 handle methods for the 3 commands. You could have the same class handle a number of commands, or you could have different classes handle different commands. Depending on what framework you're using or what approach you take, you could make this something like I handle events. Say, if I were to type it, I handle I handle command of register command. And if that makes sense in your context, you could do that. The infrastructure I have does not need that, and I've chosen to avoid it. Right, so let's see what happens when this thing handles the register account command. It simply creates a new account by calling the constructor new account, and then it calls repository.save. When the debit account command comes in, it gets the account from the repository by the ID. So repository.getById account, command account ID. And then it calls the debit method. And lastly, for the unlock, it does the same thing, account.unlock account. So it's quite simple, quite trivial. But the idea is that if you have any external dependencies to carry out this operation, you would do this over here. none of those external dependencies would actually get passed into your aggregate objects. In this case, we have a single aggregate, and we call it account. We can see that it derives from aggregate, and this is all it is. Now, let's kind of go through the aggregates one operation at a time. The first operation we have is a public constructor, and all it does, since we're not doing any validation for anything in this case, you could put some validation in here, but we're saying if you get a request to create an account, simply create it. And instead of actually creating the account or setting properties, what we do is we call a method apply, and this apply is in the aggregate base class in the framework, and we'll take a look at the framework later. But anyway, so this is saying yes, an account has been registered, so this is where the decision is actually made. This is the place where your decision is taking place. So you're doing apply new account registered event and raising that event. Sure. Now what the framework's doing here is a number of things. Firstly, when repository.save is called, it will publish this event to any subscribers. We'll see how that gets hooked up later when we look at the message bus. Apart from that, if you have a method called updateFrom that takes in a single parameter of type account registered event, that method would also get called. So in this method, you would actually update the bits of the event, the state variables that you have that are required for future event processing. Okay. Apply account registered event, that would cause a call to update from account registered event. And over here, we're simply setting the balance to initial balance. If you look at the state variables, you'll see that we only have balance, number of overdraws, and is locked in the account class. We don't have other things like name, email, well, that's the only other things in this example, but we don't actually have any references to those properties. The reason we don't is that those properties are not needed for the operations that account is doing. Okay. Right. What this update from means, this is just a convention. The framework does this through reflection. It looks for an update from method with that signature. If it finds it, it calls it, otherwise it doesn't. Different people do this differently. You could have explicit registration handlers in your constructor to do this. I find the convention quite simple to follow. Right. Let's take a look at the second method that says debit. In the debit, what we first check if the account is locked. If it's locked, we are throwing the account locked exception. Next, we check if the account is greater than the balance. If it is greater than the balance, then we apply a new overdraw attempted event. And then, if the number of overdraws is equal to 3, we lock the account. Notice we're not actually setting the properties, the fields is locked or number of overdraws in the public method, or rather the command handler. We are doing that in these update from methods. So where you've got overdraw attempted, we increase the number of overdraws. And then update from account locked, we set is locked to true. So that locks the account. And that's, and lastly, if the amount is less than the balance and the account is not locked, then we apply a account debited event. And that simply causes this to be called. It decreases the balance to event.newBalance. And unlock account as well. It's pretty obvious what it does. If the account's locked, it raises a new account unlocked event. And that causes update from account locked to get called, which resets the number of overdraws and sets is locked to false. Right. So why did we set the private state variables in these update from methods as opposed to in the public methods themselves? Well, here's where that comes in. When you're doing, say we're processing the debit account command and we're doing repository.getById, what we're actually doing is we're not loading the account from some sort of relational storage. In fact, if you look at the schema for, let me bring SQL Server Management Studio in. Wow, that's big. If you look at the schema for the tables that are here, quickly create the diagram. You can see that there aren't really any accounts here. All we have are event wrappers and streams. And if you look at the columns that are there, it's stream ID and current sequence. That's used for optimistic concurrency. And we have event wrappers, which has the event ID, stream ID, sequence, time stamp, event type, and the body of the event. You'll also notice that we don't actually have any account things stored in the database at all. If we do a query on the event wrappers, you can see that we have these events that are of, say, overdraw attempted, account locked, account registered, different types of events. And the body is just the event messages serialized as JSON. You could use binary, you could use anything you want. But let's look at another one, account registered. And you can see that's kind of what we entered, apart from the GUID, which was automatically generated. It's just serialized JSON of the events. So we don't actually have the account data or the account object persisted anywhere. When we do repository.getById, what's actually happening behind the scenes is that all events that are related, all events that were generated by that account with that ID are fetched. Okay, and after fetching, it's played back through an empty instance of an account. And what do I mean by an empty instance of an account? I mean something, say, that used reflection to create a new instance of this account using this private constructor, where these fields have their default values. So balance would be 0, number of overdraws would be 0, and is locked would be false. Okay. And then what it does is it takes those events that this particular account generated and plays them back through this empty instance. And by playback, we mean that the events are passed into this empty instance via the update from method, one by one in sequence. And since the only state that we set is inside of these update from methods, when these events are played back, it will be as though the account was not persisted or retrieved at all. Sorry, we had a Q&A question, when is playing with balls of mud? That, I think, has been cancelled. Sorry. Right. Okay. Right, so the events are played back one by one, and when it's all done, these variables have the exact same values as they had before the aggregate was saved, i.e. as it was at the end of the previous operation. The benefit of this is that we don't have any sort of public getters or setters, public properties, public fields. That means we don't couple ourselves to anyone using those properties or fields. All of the state is maintained by the account based on the events that this account generates. So the account itself is responsible for maintaining its own state. Right, so that's where the convention comes from. It's basically used for hydrating the account from its previous events. Right, so next what do we look at? We can, the next thing that happens is, where do these events actually go to? So if we go back to the diagram, these events go to the event store, but they're also sent to the projection handlers, or read models, or denormalizers, or whatever you call it. And these are simple mechanisms of storing data in a way that is friendly for querying, so that when queries come in, say the application or the UI or some report asks for some data, you don't need to do complicated processing. You don't need to jump over 6 or 7 tables via joins. You take your data that you have and you simply return that. So let's take a look at what data we actually have. So if we go to this screen, we can see that, oh, let's create a second account. Let's see. It's at example.com. Right. So in the home screen, you can see that we have a list of, well, account IDs and their names. Okay. Similarly, over here, we have a list of account names and their emails. Also, we notice that if an account is locked, it has an unlock button. So presumably this view also would need the account's ID. So we have one projection called account info. What that has is the account ID, name, email, and whether the account is locked or not. Okay. The account info projection looks kind of like an application service, but it's much simpler. It doesn't interact with the domain, it doesn't talk with other things. All it does is it listens to particular events that it's interested in, and it updates some data. In this case, what I've done is I've kept an in-memory list, although you could inject some sort of data structure facade or something, or some sort of repository or whatever that would let you store the data somewhere else, like in a database or a document store or something. Right. So what's happening when the account is registered? What we're doing is we're adding a new entry to the account infos. We're checking if we have one with the matching ID, and if we don't, we simply add it to the list. Similarly, for the account locked event, we find the appropriate account info using first or default, and then we lock it. And last, for the account unlocked, we find the appropriate account, and we unlock it. Now, this account is not an instance of the domain account aggregate. This is an instance of account info, something that is geared towards presentation. And by presentation, we mean, this window of data over here, and this window of information over here. So when the controller needs some account information, all it does is, let's have a look, is it does readModel.accountInfos. Similarly, readModel.accountInfos for the two operations. Anyway. Right. If we look at the other screen for the users, over here you can see we have some windows of data, if you will. One is Hello John, so the screen needs to know about the user's name. Also, it needs to know about the user's balance. We have another, say, window of information that has a list of notifications for that particular user. So John has these, Stuart has a lot less. He just has his account has been registered. He's not done much here. Okay. So for one window of data, that's account balance, we say we've got the account ID, we've got the name, and we've got the balance. And the projection for that maintains that data. So when an account is registered, it updates that, and when an account is debited, it debits that account, or decreases its amount, if you will. It doesn't care about the other events. It doesn't care about when an account is locked or unlocked, or what sort of business rules are behind an account getting locked or unlocked. All it knows is that these events are pushed to it, and it needs to keep this bit of data up to date based on those events. Similarly for notification, we have the account ID and the message, and the notification projection. It listens to a few more events and simply creates that log of things that the user needs to see. Right. That's where this comes from. Okay. So, and the read model facade is basically a helper type thing. So the controller can simply look into one place rather than have to know about all these different types of projections. It just goes instance.readModel.account balancers or account infos or notifications. Right. Okay. So we've seen that we have commands, we have events, we have an application service, we have read models, we have projections, we have a read model facade, and then we have a controller. And somehow we need to hook all of these things together. Now, this might seem kind of complicated, but it's actually quite simple. It's all done in this single place, a configuration, or as many people call it, composition root. If you were interacting with an IOC container, this is where you would set this up. You'd set up the dependencies here. Instead of using a container, what I've done is I have set up all of these in code over here. We've got, say, 1, 2, 3, well, how many events do we have? 1, 2, 3, 4, 5. 5 different types of events. We've got 3 handlers, so I've written this bunch of code. If you wanted to, you could use reflection to do this automatically. You could use containers to resolve these, or you could take other approaches as well. Over here, what we're doing is we are instantiating an instance of a bus. And we are newing up the command service and the various projection handlers. And we're telling the bus that this command service's handle method wants to subscribe to this type of command. Similarly, the command service's handle method wants to subscribe to that type of command and that type of command. This projection's handle method wants to be a subscriber of account registered. So whenever an account is registered, this info projection's handle method will get called. So it's a very basic in-memory pub subsystem. There's no persistent message queues in place or anything else here. This is all done in memory. And all of this is hooked together via the bus. Right, we'll get to this part slightly later. Okay. Right, so this is where all the configuration things are hooked up. They are kind of joined together, if you will, composed. And when the controller requests come in, it simply looks up these things in the configuration. So configuration.instance.readModel gets into account's infos. Let's see, configuration.instance.bus.handle gives that, well, that's what it needs to call whenever that command comes in. So in terms of what the home controller needs to know, it's a lot simpler than what it would have to know if it had knowledge about the various services.
Look at your face. You don't want to play with him.
Hello?
What?
Okay, cool. I'll continue. Right. Now, it seems like the framework is doing lots for us. It's fetching events from the event store. It's hydrating aggregates. It's got a bus that carries messages, i.e. commands from the application to the domain, and it carries events from the domain to the read models. But it's actually quite simple code. There is some magic to it, as into the update from thing, which uses reflection, but other than that, it's very basic. And the entire framework is actually 171 lines of code. Granted, we do have a SQL event store, which is 150 lines of code, which is basically just SQL statements and SQL commands and that sort of thing. We could optimize this a lot more, obviously. but that's all there is to it. If we look at what the aggregates base class does, it has a list of uncommitted events. It's got a version number. It's that it uses for optimistic concurrency. Here's this load from history thing. The repository gets these events, it loops through the events, and calls aggregate updater.update. And this is what does that reflection thing to call the update from methods one by one. Right. This code will be up on GitHub, and it is fairly trivial, so I won't go through and explain all this. I will, however, explain the message bus. All this is doing is it maintains a dictionary from type to a list of actions. You register handlers for particular types given by T, and when handle comes, it ensures that it has exactly one handler, because a command should only ever go to one application service, and it calls that. Otherwise, when a publish comes in, it publishes to all registered handlers for that particular type, and all types that is assignable from that type. Okay. So, right. The projections that we have, they're not actually updating any sort of persisted storage. The only persisted storage we have in this simple application is the SQL Server. Is the event store in SQL Server. So, how do the read models get hydrated? So, if you stop the site, this is what happens. Remember, the projection data is held in memory. Okay, you can see that all of that data is still available, and we haven't lost anything, even though we're not actually holding on to anything. And what's happening is those two lines at the end of configuration. When the application is booting up, it tells the event store, "Give me all events ever," and it simply publishes them. Now, this might seem kind of, erratic at first. You're getting all the events for an application that have ever taken place. But for a lot of applications, that is actually all you need. Unless you're dealing with huge amounts of data, this would take milliseconds. If you are dealing with moderately sized amounts of data, you could see that your startup process could have, say, 5 minutes, 10 minutes even. But all of that data is actually held in RAM. Now, I'm not saying this is going to be appropriate for all applications, but for many applications that could be enough, or even for certain parts of certain applications that may be enough. For other parts, you may want to persist your read models into something else. Okay, let's actually move on from looking at the project. Let's look at some of the testing that's involved. I've actually got two tests for the domain, if you will. And if we can fit this on screen, can we? Yes, just about. Okay. That's actually a test that checks that the account should be locked after 3 overdraws. Okay. Since I don't have strongly typed events, I can't say the event has the event source ID on it. My testing frameworky thing that expects a dictionary of objects to a list of objects. The dictionary of object, the first parameter would be a ID of the event source, or aggregates, or whatever. And the second parameter would be a list for that particular aggregate. So we're saying for this account, these events have taken place. So that's your given. So you've got given these events, when this happens, which returns a command, and these events should occur. And then you are simply hooking up the message bus to a particular application service. So we're saying SVC equals new accounts application service, bus.register handler debit account command service.handle. What the testing framework is doing is it's actually saying that if you've got these events in your event store, and it's using an in-memory event store, then when this command comes in, it's going to put that command on the message bus, that's hooked up over here, and then it's going to say these events should occur, and it's using a open source library called compareobjects.net to ensure that the messages are actually equal. Okay. Now this might seem verbose. You can simplify this, or rather you can, using lambdas and delegates, you can reduce the amount of code necessary for this, but this is just to show what can be achieved. Okay. Let's look at the second test that says that locked account should not allow debit. Just like before, we've got a previous history of events. We're saying account registered and account locked. When this happens, debit account, this exception should occur. Say return new account locked exception, and you're hooking up the same thing over here. So all of your tests would kind of look fit into a similar structure that says, given these events, when this happens, these events should be generated, or this exception should take place. Okay. How are we doing this? Well, that's all in test base. That's actually an NUnit test fixture that has a test method. These are the abstract and virtual methods that you need to override in your tests, and this is the amount of code that's involved in actually carrying out that. This is where we're using that compare objects framework thingy. Okay, so that's NUnit running this, but there is something interesting here. You'll notice that although we're testing accounts, we are not actually calling out to the account class anywhere in this. There is no reference to the account class at all. We're hitting it at the application service level. We're still using a repository with an in-memory event store. So you're kind of testing the whole loop, only instead of using a SQL event store or a Raven event store or some persistent event store, you're using an in-memory one. Okay. If you were to refactor refactor or change how the application service goes about dealing with these debits and these credits, then you're free to do so without actually having to touch any of this code. So the test code would remain intact for most of your changes, unless some business logic actually changes. Right. And you can actually take this further. This is using the NUnit test runner to actually run the tests, but you can very easily create a console application that produces very readable test reports based on that. So I've written this out to a console application. You could do the same, print it out to a PDF, or send it out to some HTML pages or a wiki or something. But if you look at the reports, you can see that it's very readable and understandable. You can see that accounts should be locked after 3 overdraws. You say given account number John abc.example.com registered with initial balance of 500. Overdraw of 600 is attempted on account. Overdraw of 600 attempted on account. When an attempt is made to debit 700 from the account, then overdraw of 700 attempted on the on account, and that particular account is locked. So that's your test. Okay. Similarly, you're saying given account is registered with an initial balance and account is locked, when an attempt is made to debit that, then expected account is locked and cannot be debited. Now, anybody can read this and not just see what you'd see in terms of, say, mspec or specflow in a single line of some sort of parsed and generated output with some magic. You've got some very human readable tests going here, and this is actually executing the test. So if we were to say change this to what was the test? Right. Say these events should occur when this happens. Let's say we change that. We change that to 70, and then we run it. You can then see that the output actually says that that particular test failed. Okay, so that test failed, that test has passed, and you can see it in red that these events were expected, but you found these things. Now, how are we getting these human readable things from the tests? It's not very difficult. If you remember, all of the events and the commands, they're simple flat data structures that have data, and their name represents what they represent, or rather their intent. So what you can do is simply override toString, and overriding toString, we can give that more meaningful human readable sentences that we're seeing in the test output. So over here. Now over here, you're not even using NUnit anymore. If we look at what the format is doing, should have called it something different. That's some nasty, dirty code that I wrote in about 30 minutes this morning. But what it's doing is it's looking for all the tests of a particular type. Ideally, if you wanted to make this prediction grade, you would inject the assemblies that you want to test, perhaps via the command line or something. But then it creates instances using activator.createInstance for the tests, and then it calls out to those methods that are in the test. So when this happens, these events should occur, and then it compares to what it goes. It compares what the test expects to what it actually generated, and then the rest is just setting the formatting for the colors. Most of the code in this format is actually just console.foreground color equals console color.cyan or something, right? So in this way, you can have some very nice, meaningful tests for your application domain. You can do something similar for the projections as well, since they're actually listening to a history of events, and they're generating somewhat flat data structures that are used in read models. Right. So we've seen some benefits in terms of testing. Let's have a brief discussion about other benefits. So in terms of DDD, in DDD aggregates, if you're doing something like, say, lazy loading and that sort of thing, it can be quite difficult to draw boundaries around your aggregates. And the definition of an aggregate is that it's just a consistency boundary. Everything else is just peripheral. The main thing is it's a consistency boundary. Everything within that boundary has to be consistent with each other for every single operation. Whereas things outside of the aggregates need not be immediately consistent. They can be consistent with the aggregates after some sort of delay. When we're saving our aggregates via the repository, what we're doing is we are getting events from the aggregates. Let's have a look. So what we're doing is we're getting the events that the aggregate raised for a particular operation, and we're pushing them to storage all in one go. So at any point in time, this aggregate is always going to be consistent within itself, because it is based on the decision that it's on the decisions that it's making itself. So it's much easier to get proper aggregates using this approach. In terms of object orientation, you'll see that these message-based approaches help with things like the solid principles and tell, don't ask. The aggregates, if you will, they don't have any public state. What are you going to ask them? You won't have anything to ask them. All you can do is tell them to carry out some operations, and they either raise an exception or generate an event saying that, yes, I've done this and this and this. Right. Adding new features to existing applications. Here's a really cool thing, and you can do this at two levels. One's on the read model. Now, last night when I was scheduled to do this presentation, I didn't actually have the notification system in place at all. And I added this morning in roughly 15-20 minutes. How could I do that? I could do that because all I had to do was subscribe to existing events and create a new projection to hold the new data. And that was it. I didn't have to touch the domain. I didn't have to tell it, okay, you need to do this and this and this. I'm just analyzing the same events in a different manner to add a new projection to it, to add a new report, if you will. And this is interesting. If you have a system in production, say from 2 years back, and you're monitoring all of these events, then what you can do is you can create a new report today, and whether it's persisted or not, you can simply take all of your events and play them back through the new projection, and at the end of that playback, you could perhaps do that offline, not live. At the end of that playback, that projection would be up to date with data from 2 years back. So although you're creating the new report today, your report would have data from since when you were tracking events. So you can easily add new projections to this, even in an offline manner. The other thing you can do is in terms of the aggregates themselves. So say when we first started, we didn't really care about locking the account. So we didn't have this. So account locked, we didn't actually have that. And we didn't have that. Whoops. That thing. And a lot of people actually made these requests, and there was no sense of account locking. We have historical data that doesn't agree with the new business rule that accounts should be locked after 3 overdraw attempts. Using relational approach, if you were to add this new rule, typically you have to do a costly migration, or you turn off some indexes somewhere, or you set some constraint off, or you see columns filled with nulls or default values or zeros or something. And if you've worked with some sort of legacy application, it should be fairly common that you have data in your database that makes absolutely no sense today. Whereas since we're tracking these events, what we can do is we can come back and add these features to it. Whoops, sorry. Control Shift break. Okay. Joy. How's it even debugging? It should even compile. Right. And you can come back and you can add these things, and you can say that well, not with this part of code, you would need some code changes in the aggregate itself, but you can say that up until this state you can ignore these locking behaviors, but from this date forward you would actually cause the account to lock. So you're maintaining historical data, you're honoring what happened in the past, but you're also adding new behavior to your aggregates without a great deal of change elsewhere. Now there are going to be some cases where that sort of change won't be possible, and you may need to do a migration of your events. But even then, versioning of events is much simpler than versioning a relational database, because in the former case you're just versioning flat data structures with no relationships in them, whereas in the latter case you may be versioning 6 tables all together at once, which can be slightly more difficult. In terms of integration, you're essentially communicating what's happening in your application through messages. And in terms of integrating 2 different applications, what you typically do is you would generate messages to do the integration anyway. Whereas over here, you're getting them for free, or you could have a projection that listens to your internal events and raises some external events when necessary. We've already talked about versioning. Regarding team roles, this can be quite interesting. Your UI experts can obviously work in your UI thing. Your domain experts and skilled domain modelers, they can work on the domain. But in the presentation side of things, you have very simple structures that simply listen to events and create some sort of view on the data. The risk with that is also quite limited, because your single source of truth is your event store. So if you made a mistake in terms of how a particular projection works, you can simply throw it away and play back all the events, and it would be as if it were correct all along. For certain scenarios, this may not be applicable. Even then, it would typically be easier to recover from those types of failures with this sort of architecture than it is to recover from a mistake that you would make when everything is entangled together. In terms of performance, you can easily see how this can be sharded quite easily. Your presentation data is quite flat, and you can distribute it across various machines. Your event store can be partitioned by aggregates even. You can have certain aggregates on one machine, certain other aggregates on a separate machine. There could be workflow. There's other more advanced things like workflows and sagas and that sort of thing. But in general, you've got these small bits of data that's independent from the rest in terms of their structure that you can shard across various nodes or clusters or whatever, without having to worry about things like, oh, this table is related to that table and that table is related to that table. How do we now put this, how do we scale out to 20 different servers? You just don't have that problem with this approach anymore. Right, so that's kind of all for the presentation today. If you have any questions, could you please type it into Jabber or Q&A, and I can hopefully answer. Can I link the Git? It's not on Git right now. It will be on Git today or tomorrow. Tomorrow at the latest. Although where it will be is here. So the version I'm presenting, I'll probably upload that today or tomorrow. Apart from that, the earlier versions of this, some of it is in this URL here, and some of it is in this URL here. So github.com/ashik, that's my name, single file CQRS, and roughing it Canary Wharf, because apparently Rob of the Canary Wharf.NET user group thought roughing it would be a good session name for that particular topic. Anyway, right, any other questions? Right. Okay, so if you have more questions after looking at the Git repositories and stuff, you can catch me on Twitter. Send me an email. I'll be happy to answer any and all questions that I can. If you're interested in this sort of architecture going forward, you can look at tddcqrs.com. And that has a, although slightly dated, January 4, 2011, but it's got some great introductory material to that. There's also Rinat's blog at abdulian.com, and there's a whole load of other guys working on this. So I think cagile.com, that should be Eve's account. Oh no. There we go. You might want to follow that guy as well. There are some frameworks for this. There's NCQRS, which I kind of covered last year. There's Jonathan Oliver's Common Domain, but Common Domain works very nicely with a really good event store called Event Store, of all things. That's Jonathan Oliver's project. It's very full-featured. It can use a whole load of persistence mechanisms, but you might not actually need all of those features. It might be complicated to get started with. And typically I've found myself simply writing whatever I need myself rather than actually leveraging one of the existing frameworks, simply because you don't actually need too much code to write a framework for CQRS and event sourcing. I mean, apart from the event store there, that's 170 lines of code, and the event store itself, yes, it doesn't have all the bells and whistles, it doesn't have snapshotting and all the other things, and which, say, this event store over here has. Someone's kindly linked to it. Yeah. But the other thing is that your application code is so much decoupled from any of these implementation details, like, say, whether you're using an in-memory one or a SQL one or a Raven one or Jonathan Oliver's. Typically, this one line of code would be what you would change for any of that. So, even if you start off with something very simplistic like this in-memory thing with SQL Server, you can then move on to, you can improve the infrastructure, put in a message queue if necessary for performance, put in some persistence on the read side, but even then, you wouldn't actually be touching your application code, you'd be touching your infrastructure code, and you'd be hooking it up at your composition root. So you can start developing with something really simple, something that's not expensive to develop, and may have some problems like, say, scale out or transactional stuff or DTC or something else. And then if you hit problems, at that point you can change the infrastructure, upgrade the infrastructure to meet your new requirements without having to go through and change all the application code that you have. So scaling becomes a secondary decision rather than a primary decision in many ways. Cool. Right. Got a question. Over the lifespan of an application, a specific object might accumulate a significant number of events. Okay, right. This is a good question. Have you ever experienced performance issues for needing completely hydrate objects from instantiation? Yes, that can become an issue. There's a number of things here. Firstly, an aggregate generating a huge number of events typically points to an approach where modeling has been done towards what things are rather than what things do. With a typical application, you start off with things, like, say, account or person or product or something. Whereas here, what you should start off with is messages. So these events, these commands should result in these events, and then you model your aggregates around that. And that typically leads to a scenario where your aggregates have little states, and they won't be generating too many events. If they are, chances are there's more aggregates, possibly even as workflow or saga hidden in there. Okay. So that's one thing. That's a sign of trouble. Your aggregates is generating too much. In many cases, that may not be possible to avoid. In many cases, an aggregate could actually be generating lots and lots and lots of events. In that case, you can use two different approaches. One is you can use caching. So on the first hit, you hydrate and you store that in memory somewhere. On subsequent hits, you use the same instance. So that's helps in terms of performance. If you're distributed on multiple servers, that sort of caching might not help. You might need some sort of affinity in there as well. Cache invalidation is a big problem, so it may not be the best approach. The other approach is to use a technique called snapshotting, or a memento pattern. In that case, aggregates that generate lots and lots of events would have two more methods. One method would be get memento, and the other method would be set memento. what getMemento would do is it will give an object that can be stored somewhere as serialized JSON or something else, and then later on, using that object, using setMemento, the aggregate could hydrate itself from that. And then loading would actually become a two-step procedure. For loading those aggregates, what you would do is you'd first fetch the snapshot, and then you'd hydrate the aggregate with that snapshot, and then you'll only fetch the events from the last snapshot. So if you say you're taking snapshots every 100 events, and the aggregate has generated 520 events in total, instead of loading up 520 events, you're loading up one snapshot and 20 events, playing the snapshot back, and then playing the other 20 events back. So it's kind of a double-edged sword. If you are in that scenario where performance is becoming an issue, that could be a solution to it. But I wouldn't recommend applying it across the board, because if you do, then all of your aggregate loading becomes two-stage procedures, and the extra query to get the snapshot and then get the events can have a performance impact. Stuff like SQL Server and data storage in general is usually very good at loading up append-only flat small things that are kind of closely knit together, rather than relational data structures that involve complicated joins across multiple tables with index lookups and all of that things. Cool. Right, does that answer your question? Cool. Any other questions? Is it possible to wrap a repository update and the event in a transaction? Interesting question. Yes, of course it's possible. If we go back to this picture here, what you can do to start off with, you can wrap the whole thing inside of a transaction. And what that would mean is all of the things in the domain and all of the projection updates, if they are persisted, would be transactional. Any failures would cause a rollback. And that can be bad in terms of performance, but in many cases that could be all you need. And the immediate consistency that that's going to give you will means that you don't have to deal with eventual consistency, you don't have to tell the users that the computer is thinking, or you don't have to explain it to anybody. Okay. But then you might find that you have 70 or 80 projections, and you have simple operations in the domain. Now the projections are meant to accept anything that comes along. So what you the domain could reject commands. So at that point, what you could do is you could make this bit, i.e. the application and the domain, that processing, the processing of the command service, you can make that transactional, put a transaction around it, and if there's an exception, then you can tell the user that this thing failed immediately, but if it was successful, you can tell the user that this request has been accepted, has been processed, has been accepted and will be processed shortly, and you could update the read model asynchronously in a separate service. By service, I mean a separate Windows service or a separate box or something, through a message queue even, and later on these read model things will get updated. So in that case, you are benefiting the user by giving immediate feedback for failures, but for successes, you're saying that there will be an element of eventual consistency. And the last thing is, if that turns out to be a performance hit, you can then put a message queue in front of the application service and simply accept commands as soon as they come in. But then you are saying that none of this is immediately consistent, and the user you can tell the user that their request has been accepted and will be processed, and the process could fail. And if the process fails, you could do something like, say, send an email or send a text message or something. So, does that answer the question? Okay, cool. We're nearly out of time. Oh yeah, one last thing is that most of this is actually simplifying things. The idea of this is to simplify your application and make things simpler. Okay, if something turns out to be, this is becoming really complicated because of this, then it's a sign that it's modeled wrong, or B, this type of architecture is not appropriate for that particular scenario. This is CQRS and event sourcing is mostly going to help you, say, cover your behind in case changes come or new requirements come. Okay, it does involve some more coding. It does mean you actually have to model aggregates. You can't simply go into a database and update a column in case of something goes wrong. Maintenance tasks turn out to be done via console applications or green screen applications rather than something like SQL Server Management Studio, and that does take effort and it does take time and it's a different mindset and you have to learn it. If it doesn't make your life simple for a particular application, maybe it's not appropriate for it, or maybe you need to think slightly differently. Okay, right, we're almost out of are there problems hydrating on a per aggregate basis and avoid loading your entire dataset on application start? Right, so something like the LMAX project, they kind of hydrate the entire application and run off memory. Okay. In a traditional transactional, user response type of system, loading per aggregate usually works better than loading the entire event storage into memory, particularly if you have multiple servers. So if you're doing something like load balancing and one machine generates some new events, you need to be sure you propagate them to the other machine. There is machines. That's not to say it's not applicable. You can do it. It's just a bit of complexity that you need to be aware of, and I'd recommend doing that when you need to, rather than starting off with that. Okay, cool. If you have more questions, just use Twitter or something. We're almost out of time. I think a new session is about to begin because it's almost, well, an hour and a half. And if you're interested in JavaScript stuff, I've got another talk today later on. Hopefully see you then. Bye.